Hello, this is exercise 4b. We're going to look at complex conjugates today, and also how to use complex conjugates to be able to divide by a complex number. So first of all, let's just have a look at these complex conjugates and see how they, we can use them. We've got a starter briefly. Let's have a look at this first then. So it says just add these together and do whatever it says. So I'll do the first one, you can finish them off. So it says 2a, well 2a is obviously 2 lots of 1 plus 3i, plus 3c, what was c? 2 minus i. So multiply out those brackets, just it's basic maths really, 2 plus 6i for the first one, plus 6 minus 3i. So what's that give me? It gives me 8 plus 3i. It's just common sense really. So have a go at all of those, make sure on B, where it says AC, this is a double bracket. You need to do that. And I'll also point out one thing. I squared, remember, is equal to minus 1. See if that helps you along the way as well. So I'm going to pause the video, and you've got 3 questions to do. Okay, so I'm hoping you've done them now. If you haven't, pause the video again and do them, but otherwise, well, I'm going to just finish these off. 1 plus 3i in there, and what does C say? It was 2 minus I. Okay, so if I multiply this out, I get 2 minus I plus 6i, and then this is the weird one, minus 3i squared, but I've already said up here I squared is minus 1, so whenever you get an I squared, change the sign, get rid of it. I don't want to see I squared as a general rule. What's that give me? 2 plus 3 is 5, I reckon plus 5i. Now b squared, well that's presumably then just 6i times 6i, and that's 36i squared, but I've just said to you I squared is minus 1, so this is really minus 36. A plus b minus c, what's that? That's 1 plus 3i plus 6i minus 2 minus a. That's the only hard thing about this. Make sure you don't make a dark mistake with the minus or minus. So 1 minus 2 is minus 1 for the real part, and for the imaginary parts we've got 3 plus 6 is 9i, minus a minus is another one, plus 10i, I think. Yeah, the right answers, let's check. Yeah, so I've got all of those right. So the starter's done, and now let's look at complex conjugates. So when dividing by a complex number, we have to multiply top and bottom by the complex conjugate z star. Now, before I go on to this, let me just remind you of a technique that we've seen in the past. So if I said to you what is 5 divided by 2 minus root 3. Now this is a GCSE topic. You might recall that what you're meant to do when you do this is write it out again, but this time you're going to times top and bottom by, well, you probably got told to change the sign on the bottom. I'm going to multiply top and bottom by 2 plus root 3. And this trick works basically for the difference of 2 squares. The difference of 2 squares says if I times the 2 by the 2, I'll get 4, I'll get plus 2 root 3, but then minus 2 root 3, and they will disappear. And then I'll get minus root 3 times root 3. So if I just finish this off, so 5 times by 2 is 10. 5 times by root 3 is 5 root 3. So the top's easy, when this one is. Anyway, and the bottom's easy as well, but look at it, 2 times 2 is 4, and as I was saying, when I do that times that and that times that, they will cancel each other out. So the only thing I'm left to do really is that times that, which is minus 3. And my answer then is 10 plus 5 root 3, because by fluke really, I've picked an example with 1 on the bottom when the answer, and if you divide by 1, it doesn't change. So that is the method for doing what we're going to do, and I'll show you now what we're going to do. So it's probably worth my while just rubbing out this little bit here, just so it doesn't interfere with what we're doing. And you can see then that I've defined a complex conjugate for any complex number z equals a plus bi, and we often use z for complex numbers. But the complex conjugate of this is written z star, and it's a minus bi. Notice how effectively the only difference is the plus has become a minus. The first number, the real number, the real part of this hasn't changed. It says a, it says a. The only thing that changes is that sign. It says plus bi, it now says minus bi. So that's what I want you to write down in your book. That's called a complex conjugate. And it says find z star when z equals this. The easiest questions in the world. Z star equals, well, it says 3 minus 2i. Well, it becomes 3 plus 2i. Just change the sign of the imaginary part. This one, z star equals minus 8 plus 2i. Well, it's still minus 8. That doesn't change. But plus 2i becomes minus 2i. So these are complex conjugates, and hopefully my answers say that. Yes, they do. So why did I show you that example? Well, because we are going to do something very similar when we divide by a complex number. So 2 plus 4i divided by 3 minus 5i. Notice I'm going to write it again, and I'm going to times top and bottom by what's called a complex conjugate of bottom. Notice it's 3 plus 5i. And that is very similar to what we did with square roots, and when we try to rationalize the denominator in that first example I showed you just now. So I'll do the top. You treat this like a double bracket, because there's more than one thing on here. 2 times 3 is 6. 2 5i's are 10i. 4i times that is 12i. And 4 times 5 is 20. Notice the I squared, so I'm just going to write minus 20 because I know that I squared is minus 1. This is something that comes up loads. Do the same for the bottom. 3 times 3 is 9. But notice how 3 times this gives me plus 15i, but that times that gives me minus 15i. They will always cancel out. So I'm left with just this term here. 5i times 5i is 25i squared. Notice this is a minus 25i squared. So I want to write minus 25i squared. But before I do, I remember, hang on a bit, I squared is minus 1. So it always becomes a plus. Always becomes a plus. My final answer then, let's just do it. I've got 6 minus 20, that's minus 14 plus 22i. All over 34. Now, that could easily be written like that on your calculator, or it might split it. And you could be asked to write it in this form as well. So just look out for this. Sometimes they say write your answer in the form a plus ib or something like this. And that means they don't want a fraction. They want you to split it in 2 parts. So let's see what I've written here. I split it. There you go. Both are right. It doesn't say how to do it. But if they'd asked for it in this a plus ib form, then that's how to do it. Here's another example. Interestingly, the bottom here is just says 4i. Now I could times it by minus 4i, and it's probably best to actually, because the advantage of doing that is I need to write. See what I need to times it by minus 4i. Minus 4i. The advantage of doing that is then the I squared will disappear effectively. I'll show you what I mean. Treat this like a bracket. 3 times minus 4i is minus 12i. And the I times minus 4i is minus 4i squared. And before I write I squared, I think, oh no, I've got to change the sign instead. Because I squared is minus 1. What do I get on the bottom? I get 4 times minus 4 is minus 16. I want to write I squared and I don't. I just change the sign instead. So my answer is actually, well, write it in the right order. You usually put the real part first. So 4 over 16 minus 12 over 16i. I can probably cancel that down. It's easy enough, isn't it? A quarter minus 3/4i. So relatively straightforward. So that last one was okay. Let me get my pen back. Now we've got some simultaneous equations. So I should perhaps just remind you what we do normally. So I'm going to make up an example here. So something like if I had 8x plus 4y equal to 10, and my second equation was 2x plus 5y equals 9. Now, you can get rid of either x or 9. In this case, it's easiest. You can see there's a relatively easy way to multiply the 2 to get up to 8. But if it was a harder sum, you perhaps would do 8 divided by the 2 to get 4. And having got that answer, you'd go, okay, I'm going to times the bottom equation by 4. So on that basis, just looking at these two here, I think what I want to do first of all, I need to work out what I've divided by, or need to divide by. So if I do 1 plus I divided by I, what's it equal to? Well, I've got to times top and bottom by minus I suppose. And that gives me, let's just say, it gives me minus I squared, but that makes it plus 1 over minus I squared, which makes it plus 1. So actually, it's probably easier to write that as 1 minus I. So that's what I've got to multiply when I do this, my second equation by. I've got to multiply it by 1 minus I, and every one of these three terms needs to be multiplied by it. And the great news is, of course, when I times I by this 1 minus I will get this 1 plus I. That's the whole reason for doing it. It's in the same way as here. Once you sussy times by 4, you don't have to think about it. You know, so 2 4s will give you 8x. So I'm just going to write out the top equation. It's 1 plus I z plus 2 minus I w. So I'm just completely rewriting it, not changing this one at all. The only one I'm changing is this one. And when I do this, I times 1 minus I, because of this over here, will give me 1 plus I z. Now I've got to now multiply 3 plus I by the 1 minus I. So I can cheat a bit on my calculator. I've shown you before how to do it. You could do it yourself. Now I know the question says use detailed reasoning, but they wouldn't know whether or not on the exam you've done it properly. So I'm just typing this in now. And when I've done that, I have 4 minus 2i, obviously still with a w. And then I've got to times the 1 minus 1 plus 5i by this as well. Remember, you times all three parts as you would normally. So I'm just going to do that now. And when I've done that, I've got 4 plus 6i. So, fingers crossed they're right. I haven't made any daft mistakes. I'm now able, now again, when you do this normally, you would times this by 4, you get 8x, you'd get 20y, you'd get 36. And because they're the same, you can subtract one from the other. So I'm going to do the same thing here. I'm going to subtract. That, take away that, disappears in the same way as those 8x's would disappear. And I'm going to end up with 2 minus iw minus the 4 minus 2iw. So effectively I can go 2 minus 4 is minus 2. And doing the i's, I get minus I minus and minus 2i, so that's effectively plus I think, times by the w. Now I'll do the same over here. 3 minus 4 is minus 1. 4i minus the 6i is minus 2i. So you can see I've got this equation now, but obviously it involves now moving that bracket onto the other side and dividing. So again, 2 minus 2 plus I. And again, you could, I suppose with detailed reasoning, you're expected to show how you do it. You times by minus 2 minus I over minus 2 minus I. That will get rid of it. And again, they wouldn't know if you've done it properly or not. If you multiply it out, you end up with, on the top, I'm going to get 2 plus 5i minus 2. And on the bottom, I'm going to get 4 plus 1. Well, that's quite nice actually, because it gives me 5i divided by 5, which is I. So I get I've finally got a w. I've got the answer for w. And now I need my z as well, so I have to sub that into one of my two equations. Doesn't matter which one. I'm tempted to go into the bottom one. I've got iz plus 3 plus I w. Now w is such a nice number, it's just I, equals minus 1 plus 5i. Tie this up. I've got iz plus 3i. I squared, of course, is minus 1, equals 1 minus 1 plus 5i. Move the 3i over, move the 1 over. I get iz equals, the minus 1 effectively cancel, and I get 2i. And if I divide by the I get 2i over I, which at long last is 2. So I think I've got my answer. Z is 2 and W is I. That's right. So we're nearly out of time. Look, there's more to do next time I have you in class, but there's only one quick question, and we'll probably need to go through some of that as well. But that's exercise 4B. Hopefully that's okay. See you next time.